friends, in this session I would explain you about the statistical inference test of hypothesis. So look at here at our screen that first I introduce what is a statistical inference. Statistical inference is that branch of statistics which is concerned with using probability concept to deal with uncertainty in decision making. It refers to the process of selecting and using a sample statistics to draw inference about a population parameter based on a subset of it. So I explain here why these tests of hypothesis are required. So if you have a coin, and we know that the population parameter of this coin, if we toss a coin, 50% chance of getting head and the 50% of getting tail. But if the coin is not fair, it is biased coin, then what will happen? Your population parameter will not satisfy with your sample parameters, whatever the sample statistics you will get over there through the sample. It won't be satisfied with the population parameter. So our hypothesis that there is no significant difference in both the population, the sample parameters would be failed, would be rejected. So there is significant difference. Whatever you are getting in your tossing, if you are tossing a coin 100 times, you are getting 70 times head and the 30 times tail, and but the population parameter says that the 50% of chances of getting head and tails. So both the parameters differ. So in this way your hypothesis may be rejected. So here we determine if you have to do the research of any topic, so you have to collect the data, or you are making research on whole population, but it is not possible for everybody to take the data of the whole population. So we take a sample, we take a random sample size. So we take the sample from that population and study on that sample population. Those in sample size we study and we find out the statistic. Now if we know the population parameter, the mean and the variance or the standard deviation, if we know the population parameter, the population statistic we know, then we could compare both. If it falls in the same population, then our hypothesis is accepted, otherwise it would be rejected. So this is the need of the hypothesis. So hypothesis is very important for making your prediction or your research work. I would like to tell about the statistical inference treats two different classes of problems. One is, look at here, I explain you on the screen. Now look at on the screen that I have classified the statistical inference. Here we have classified the statistical inference in two ways: the test of hypothesis, other one is estimation. So here first I would like to explain you about the test of hypothesis. The test of hypothesis is also called the parametric test, where the population parameters are known. Here we take the t-test, z-test, f-test, ANOVA is being done here in the test of hypothesis, where the parameters of the population statistic is where the population statistics are known, just like mean, standard deviation are known to us. Then we use test of hypothesis. Second thing I would like to explain about the estimation, or it's also called the non-parametric test, where the population parameters are not known, the unknown population parameter. Where here we take so many tests. Here the chi-square, Mann-Whitney, rank test, rank sum test, crucial Wallis test, sign test, so many, the Duncan test, so many tests are there. So there are two sort of statistical inferences. I have explain you about the difference between parametric test and non-parametric test. What are the major difference between both the tests? In the parametric test, if you look at here in the first statement, the information about the population is completely known. The information about the population, it means the population parameter, their mean, their standard deviation, their variance, we know about these all. But in non-parametric test, if you see that no information of population is available, it means we don't know about the population is a mean, population, standard deviation, and so on. So here we take the expected parameters along with these sample parameter. Now the second point, look at here, in the specific assumptions are made regarding the population. So whatever the assumption we make according to the population. In the non-parametric test, no assumptions are made regarding the population. Third one is the null hypothesis made on parameters of population distribution. So the whatever the hypothesis we say on the parameters of the population distribution. But here in non-parametric test, the null hypothesis is free from parameters. It means there is no any parameter we are taking here. So fourth point, if you look at here, the test statistic is based on the distribution. Test statistics is arbitrary. Here it is arbitrary. We are taking the expected value and we are doing we are comparing our sample statistic with the expected. So here in the parametric test are applicable only for variables. Here we take the only for variables. It is not for the attributes or for the quality. Variables means the quantity we are taking here. If we see the non-parametric test, so it is applied both variables and attributes, both we could apply this. Now the sixth point you look at here. So parametric tests do not exist for nominal scale data. Now what is nominal scale data? I explain you. The nominal values or observation can be assigned a code in the form of the number, where the numbers are simply labels. One can count but not measure it, or we cannot make the order for it. So it is called the nominal data. Like the determinants of sex, male and female, we could number it. How many are males, how many are females. Eye colors we could take here: brown, black, blue. So this sort of we could give the how many persons having the black eye color, how many. So we could give the number also there. We can give the number. We can, but we could not measure it. If we talk about the sex determination, the male and female, we are not talking about the potentiality of sex. In non-parametric tests do exist for nominal and ordinal scale both. So nominal, I have already explained you what is nominal. We could count it, but we could not measure it. Now ordinal values scale, what is called? So ordinal values of observation can be ranked, put into order 1 to 5, 1, 2, 3, 4, 5. The rating scale we could give them. One can count an order. We could count it how many, and we could give it order. The first order we are going to these, and second and third. So in this way you could give the order, but not measure. Ordinal data, if you have the house numbers or the swimming levels, you have different, or the degree of satisfaction, if you want to know the strongly agreed, neutral, disagreed, or strongly disagreed. So this sort of data we could put in the non-parametric test. Now the seventh and the last one difference is the parametric tests are powerful. If it exists, we must take the parametric test. If it exists, if we have the population parameter, we always do the parametric test. But if it is not, the non-parametric test is not so powerful like parametric test. So here I explained you about why the hypotheses are required in the research or in your statistics work. Thank you.